Well, hello, and welcome to class today. This is socks. Okay, anyway, let's go ahead and get started. Today, I'm going to give you some lab time, and there's a new lab. And the new lab, we'll take a look at here in just a second. But the lab focuses on stuff that was discussed in the last lecture, which is kind of connection objects. And those connection objects, as a quick reminder of what the connection objects are, is they are a way to abstract some of the complexities of programming with sockets, which themselves are a way to an API that encapsulates how network programming works. And these connection objects are great for local computing between two processes or communicating between two processes, or for more of a distributed model where you have a server that runs on one machine and then clients that connect to it from other places. So what we're going to do today is we're going to have a lab where you use these connection objects to do some things. And what we're going to do is you're going to be writing a program that has multiple processes that each connect to a server, and we're going to make a simple multiplayer game. And the multiplayer game here, I don't want you guys to spend a lot of time focusing on the complexities of a multiplayer game. So we're going to do something simple. It's just going to be a turn-based game of tic-tac-toe. So you're going to be making two separate program types. The server will run the game and maintain the board state and communicate with the clients, and then you'll make the client program, which will connect to the server and make moves and display the board state to the players. Now, to play, you have to have two clients that connect to the server. So the server will just be there operating the board, waiting for clients to connect. When the clients connect, they then will communicate through a connection object. So notice here's the server. There's client 1, there's client 2. So this would be like player 1, that's player 2. And here are the two connections to that server. So each client will have a connection to the server. So think of these double-ended arrows here as the connection to the server. And the server will have to communicate on those two connections to each of the two clients, player 1, player 2, or in the tic-tac-toe version, maybe we think of this as player X and player O. All right. So the server will be written to be the listener object. The clients will be written to be the client objects. All right, let's take a quick look at the lab sheet. And this is going to be a really short lecture because I want to give you time to finish up your other lab and then work on this one. But looking at the lab sheet, let me switch that over so you can see it here quickly. Okay, I brought that up. Let me switch over so you can see it. Okay, so here's the lab sheet. Let me make this a little bigger. And you'll notice that in this assignment, it says you're going to write a simple game server and game client to play tic-tac-toe. But to test it, you're going to have to run the server and then run the client, run the other client, and then you can switch back and forth between the windows to do that. So the server program, let's focus on that first since that's the core of this. So you're going to create a listener that listens on your local machine and some port. Now, the local machine, you can use the local host address 127.0.0.1, or you could use your IP address of the local machine if you wanted to then play this over the network with somebody else. But just for testing purposes, you can put the local host address in there. And then you can pick some port. And the port doesn't really matter. If you want to use that 0x1234, that's probably available if you want to use something else. But remember, the ports are essentially 16-bit numbers, and those represent essentially like the extension number that your program is on. And that's how you can have your web browser talking over the network and your music streaming going over the network, and it sorts out that traffic based on the port numbers. So we're just going to pick a port number that we're going to listen on, and then the host is going to connect to that. Now, One thing to keep in mind, some of you have security turned on your laptop, there might be a firewall or something like that. When you go to run that program, Windows might bring up a dialog box saying, hey, this thing is trying to open this port. Do you want to allow that? You should allow that. You also might need to go to your firewall settings if that doesn't happen and it's not working, and open up that port number for that application. But anyway, on my machine, it just worked. I didn't really have to change anything, but keep in mind that depending on your security level and what version of Windows you have, you may need to do something to allow that port to be open and listening. Now, the next thing we want to do is have two connection objects that we're going to accept from. You're going to accept from one, you're going to accept from the other. And that's going to embody that picture we saw here. Let me switch back for just a second here. That's going to embody that picture we had here. Here's one connection object, so it's going to listen on that one. It's going to listen on that one. It's going to accept from this one. It's going to accept from that one. Now, how does it know which one's which? Well, we'll talk about that. Let's go back to the lab sheet. Okay, so essentially what we're going to do after we accept those two connections from the client players, we're going to randomly select one of the clients as the active player to go first. So if you wanted to, you could make it so that rather than randomly selecting one to go first, you could pick whoever connected first as X. That would be fine as well. But one of them has to be X, one has to be O. So then you're going to send a message to that client that consists of the board state, an instruction that lets them know that it's their turn. And then you're going to wait for and receive. Why? Why are you bothering me? All right, and then you're going to pick or send them a message saying it's their turn. You also tell them whether they're X or O. You're going to wait for and receive their selected move. And so keep in mind that once the connection is established, then it's just a matter of sending and receiving data through that. So the client then you're going to send their message to them. That has the board state and the message saying it's their move. They're going to send a response back to you that says what their move is. When they make a move, it's going to update the board state and make the other player the active player, and it's going to send them the new board state and a message saying that it's their move. And you're basically going to repeat that of sending them the board state, getting their move, and then switching players. If the player tries to make an illegal move, then you're going to send a message back to them and not switch. So the only way you switch which is the active player is when a legal move has been made. And you're going to repeat that until somebody wins or the entire board is filled. And once that happens, then you're going to send a message that includes the final board state and the winning player to that. Now, one of the things that I would suggest you do with this is remember that connection objects make it really easy to just send Python objects through to the other end. So if I were you, I'd come up with a format for that object. It could be a class that has an instance that includes a board state and who the active player is, and you send that object across. Or it could be something as simple as you make a list, and the list has a string that represents the board state. It could even be a tuple. And then it has a message for which player's turn it is, or a message to that player whose turn it is. And so you read that, you parse that message, you print it out on the display, and you show the thing. And I'm going to leave it up to you to figure out how to do that, since this is a programming assignment. I don't want to influence your programming style. I have in mind how I would solve this. I'll let you figure out how you want to do it. Now, on the client end, you're going to connect to the server. So you run the program, it connects to that server. It waits for a response from the server that includes the board state and the command that makes it your move. It displays the board state, allow the user to input their move. I would suggest numbering the cells and asking them for a number 1 through 9, like I have below. Then you redraw the board with, once they respond, you redraw the board with a new move made. You wait for the next message saying it's your turn and the opponent's move has been made. And you basically continue that process of the server sending a message stating that until the server sends a message saying game is over and that you've either won or you've lost. or it could be a tie also. And then you display the final board and the game result. So here's some example output from mine when I wrote it and ran it. It says you're connected to server, waiting for other players. So here it would wait. And once the other player joins, then it says your X, it's your move. And then if you were on the other end, instead of that, it'd say you are O, waiting for opponent's move, ... And then when it's your turn, it'd say you are X, it's your move. Or you are O, it's your move. And then you'd pick the thing. So it asks what your move is. You put in 5. It puts an X in that slot 5. And then it waits for the opponent. The opponent, when they select their move, it goes back to this thing. You are X, it's your move again. But now it shows that they put an O in that position there. And that would continue until the board is either completely filled and it's a tie, and at that point it would say it's a tie, or if you win, it'll say you won. If they win, it'll say your opponent won. And one of the things about this you might think is, well, you could think of this as, how are you going to represent this? I would represent this as a string or a list of some sort that just has the values in those 9 positions. When they go to make a move, like here they picked 5, you have to make sure there's not already a move in that position. If there is, then make them kick it back and make them make a different move. So enforce those rules. And really, this might seem a little bit daunting at first, but it's really not. It's really a small amount of code that you need to do this. That's why I picked Tic-Tac-Toe instead of making this something like chess or Go or something like that. But the main thing I want you to focus on here is using that connection object to set up the listener on the server side, and then have the clients connect to that, send data through, receive data back, parse it, accept input. And it's really a small amount of code that you need to make this thing happen. Now, the cool thing about this is after you have this written and it runs on your local machine, you could actually make this a multiplayer game that you play over the internet, because connection objects work across a distributed architecture across the internet. So I want you to kind of focus on getting this done. Now, there is a chance for bonus points. I did have some people ask about bonus point possibilities. So there is a chance for bonus points here. There are really 2 chances for bonus points here. One is to write a graphical version of this. And I would suggest making that so you just click on, it still shows the message at the top in a font, but then you just click on which cell you want to place your move in. You could also, I suppose, make it so you click the X and drag it over there or whatever, but I would just have it so you click on the cell you want to make the move in. It puts the X or the O in that spot, and then it just changes the display saying it's the opponent's turn. They make their move. It's your turn. You click. And that's worth 5 bonus points. And then also there's this game called Ultimate Tic-Tac-Toe, which is much more complicated. It's like a tic-tac-toe board of tic-tac-toe boards. And I've linked you to the rules here, this Ultimate Tic-Tac-Toe Wikipedia entry. But if you implement that in, then and include the entire board and rules of it, then that's 10 points for that. So there's a chance for some bonus points here on this lab. This first one is pretty easy. I would suggest using, there's some Python modules, Pygame, there's another one, Piglet. There are other ones out there as well. You could even do it in OpenGL if you wanted to with PyOpenGL. Or there's a number of other options as well, Visual Python. But I would suggest that one of the cool things about this graphical version, you don't have to change any of the socket code. It's just rather than displaying this with print statements, you read that string in and render it on the screen. And when you take the input, rather than having it input as a number, they would click on a cell on the board, and then that would send the number. So you don't have to change the server code at all to make the graphical client for this. You can have the text client play the graphical client play a graphical client, text versus text. It doesn't matter, because that's just how you're rendering the thing on the screen on the client side. So you only need to change the client side really to make the graphical version work. Okay, so let's go back to the presentation for just a second here. And as a reminder, 2 connections get created to the server. The server then randomly picks one. It says, hey, you're X. This one then makes a move. The move comes back in. This then reads that move. If the move is legal, it updates the board state and then sends the board state across to this one saying, hey, now it's your move. They make a move. If it comes back through, if the move is legal, update the board state. Hey, it's your move. And that process repeats until the board is filled or somebody wins. And somebody does win, you send the message across to both clients saying, hey, X1, here's what the board state looked like. Hey, X1, here's what the board state looked like. And then essentially you could then, there's a couple options there. If you wanted to, you could basically disconnect both of those clients and then go back to waiting for new clients to join. Or if you wanted to, you could code it so they have an option to play again. I'll leave that up to you to do. Really, once you've gone through one game, you could make it so all of the things close down. I just want to make sure it works for one game, really. Okay, now we looked at the lab sheet. So what we're going to do for the rest of class today is I want you to go ahead and work on that assignment. So I kept this lecture short to give you lab time to either finish up the previous lab or get started on this one. But go ahead and start working on that now. Don't procrastinate. Because there's going to be more material in another lab coming up. And one of the things I don't want you to do is, if you work on that now, then you have some good chance at getting those bonus points. And if you needed those bonus points on the midterm or want to bank them for the final or want to have a little breathing room, go ahead and get that done. And really, the amount of code needed to get the graphical version of that working once you have the whole thing done, it's really not that much. But go ahead and work on that. Everybody stay safe and let me know if you have questions or problems. I'm here to answer those questions and help you with those problems if you have them. But work on the lab soon and get started on that. And that's it for today. And I'll see everybody soon.